So hello everyone. Today is our first lecture on machine learning. Machine learning is basically a part of data science. In data science, what we do is we basically do various things with data, analyze data, we create predictive models. A lot of things comes into data science, and a part of data science is machine learning. Okay, so today is the introductory lecture on machine learning, and we're going to see what are the kinds of machine learning and the types of learnings that we can do from machine learning. Okay, so the introduction. Machine learning is programming computers to optimize a performance criteria using example of data or past experience. So basically, when we have what we have been doing till date is programming. Okay, the basic difference between programming and machine learning is that in programming we already know the rules on how to get the output. Right? Say if I say that write a program for generating the addition of two numbers, what do? You know that you have to take two numbers from the user and you have to just add it. Okay, and you get the output. But in machine learning, the thing is absolutely different. Here, we already have data from the past, which we already have the answers for, and we have to find the rule as to how to map this data. Okay, now say I tell you, how do you predict that whether it is going to rain today or not, depending on, say, I gave you some parameters. Say I gave you today the wind speed is this much, today the humidity is this much. Do we know anything, any formula to predict that? No, we don't. For that, we have to take the help of machine learning. Okay, because in machine learning, what we do is we basically learn the pattern as to how the outputs are changing with the inputs. Okay, so that is the very basic difference between normal coding and machine learning. Machine learning, we always try to learn the pattern or try to learn how they are mapped to the output. Okay, whereas in basic computer program, we just take the inputs and generate the outputs based on some rules that we already know. Okay, now learning is used when human expertise does not exist. Like we don't know, right? We don't actually know how to predict that whether it is going to rain today or not based on some parameters like humidity, wind speed. We don't have any formula to do that. Okay, and there are other areas where machine learning is also applied. There are speech recognition, solution changes in time, solutions to be adapted to particular cases, user biometrics, the fingerprints we use in Aadhaars, and so on. Okay, various fields machine learning is being applied to. What we talk about when we talk about learning. Okay, learning basically means learning from experiences. You can think like in humans also, what we do, we experience things and we learn. Okay, at first when we are born, we don't know how to walk, and by the time we start walking, we fall, we again fall, and then we slowly start experiencing then how to walk, and we get the hang of it. Okay, machine learning is like that only. The more data it has, it learns the pattern and comes to a generalized approach as to how to get to that output, and it generates a kind of mapping to do that. Okay, now data is cheap and abundant is not very true. I completely don't agree with this one, because data is the new fuel, as we say it, because data is extremely expensive. At times due to lack of data, we can't learn how to predict for future, and if there is not much data, there is no data science. Okay, there is no data science without data. If there is no data, we don't get to run any algorithm. Okay, so one of the example is customer transactions to customer behavior. Now say you may have seen when you are shopping on, say, any online website, say Amazon or Flipkart, you may have seen that when you again visit that site, the people there show you some similar things that you have purchased earlier. How is that possible? Or how do they know your buying behavior? Because they are collecting each and every data. They are collecting the data about what goods that you purchase, when do you purchase, how much quantity you purchase, everything. So the next time when you come to their website, they can enhance your experience. They will only show you those products you may be interested in, and that is the reason today Flipkart, Amazon, and big e-commerce businesses have grown this much. Okay, so this is another use of machine learning, which approximates or estimates the buying pattern of users, which has been used by many companies like Netflix, Amazon, and so on. Okay, data mining. Data mining is a part of machine learning. Is also a part of data science, many people say. Actually, what it does is data mining is finding out important insights from data. What we find out from the data. Data tells us about many things. It tells us how people are buying, when people are buying, when there is a surge, when there is not, and many things it tells us about. Okay, so there are data mining in various domains, like in retail domain, in finance domain, the domain I am currently working in, manufacturing domain. I earlier worked on this manufacturing retail domain as well, but not for a very long time. My especially the domain expertise is on finance. We have medicine, a lot of medicinal drug discovery things, like researches are going on around data science. Bioinformatics and web mining, like search engines, they collect data from search engines to optimize human behavior, and a lot of research is going around this area. Okay, So this is one field that has enormous opportunity, and in order to utilize its full potential, we must have a lot of data. Okay, so data is the new fuel. Okay, now let's move on to the next slide. What is machine learning? Okay. Machine learning is basically what I told you. It is like finding patterns in the data where we already have the output and we have the input, and we try to map what kind of mapping is it. Okay, say I am given a function y equal to f of x. Okay, y is equal to f of x. So when y is equal to f of x, that actually means that there is a function that maps x to y, where x is the independent variable and y is the dependent variable. So depending on the type of input that I give to x, f, it generates output. In machine learning, we are actually trying to find that f. What is that f? Okay, but in general, when we already know the f, it is easy. Like in computer programs, we already know that f. Okay, that is the basic difference between machine learning, as I already mentioned. Okay, so basically it optimizes the algorithms, they optimize the problem, they learn more and more, they gain more experience using more data points, and they generate an optimized solution, the best solution to approach that problem. Okay, we will also see practical implementations, but it is very important that we know the theory. Applications. Okay, so there are different kinds of learning. Okay, there is association learning, there is supervised learning, there is unsupervised learning, there is reinforcement learning. So reinforcement learning is basically kind of learning where you learn on the go, like a robot or like a human, you may say. Say when you see a fire, maybe say you don't know about anything about fire, you have seen a fire first time. So what do you do as a child? You go and put your hand on the fire and you get burned and you get hurt. So what do? You already know, your brain has already learned that if you put your hands on the fire, you will get burned. Okay, and it will hurt you. So the next time when you see a fire, you don't touch that, right? So you have learned. So basically that is the way reinforcement learning works. It learns by experiences, and it learns on the go. Okay, reinforcement learning is a very advanced field of machine learning, which is not actually the scope under the scope of this course. That is completely a different topic in itself. So we will not be covering much about reinforcement learning in this course. Unsupervised learning. Unsupervised learning are those in which we don't have any outputs also. We don't have any outputs as well. So we are only given the inputs and we have to find out some pattern from that data. One of the very commonly used unsupervised learnings are clustering, where we cluster common data points together to find patterns in them. Okay, the most commonly used machine learning is the supervised learning. Supervised learning has two types. One is classification, another one is regression. Okay, the supervised learning, what it happens is that we have a particular label or output. If you have the output and you have the input, we have both these things in our data set. So we know that today the humidity is this, today the wind speed is this, and the solution as well, whether it is going to rain today or not. All of these things are given from our past experiences. Okay, from all this data has been collected from our past, and we all know that okay, if the wind speed is this, the humidity is this, the label is this. Now using this data set, we will try to learn if it is going to rain or it is not going to rain. Okay, now in supervised learning there are two types. One is the classification, another one is the regression. In classification, we try to answer in discrete form, like yes or no, true or false. Like there are basically some classes that we try to predict, whether class 1 or class 2, class 3. There are multi-class classification as well. But in regression, what it happens is we try to predict some number, continuous value. Okay, say we are trying to predict the temperature tomorrow. Okay, that is going to be the temperature can be anything, like 37, it can be 40, it can be 41, it can be 29, it can be 16, right? So it's a continuous value, there is no fixed value. But in case of classification, there is some fixed value that we need to predict, whether it is going to be say true or false, it is going to be yes or no, and so on. Okay, but in regression, the values are continuous. There is no particular value that we want to predict. It can be anything like 47.2, it can be in decimals as well. Okay, so that is regression. So association is basically a kind of learning where we try to associate with various things. Association learning is association learning is also used in this e-commerce example that I gave you, where we try to associate different kinds of product with I'm running out of an example. Say for example, your buying patterns can be a example of association learning, where you try to find out patterns in your buying. What kind of things you buy, you try to associate you to the products that you buy. Okay, we are trying to map. It's a kind of unsupervised learning, but our focus will not be on association learning that much, because that is mostly used in rule mining kind of things, where we try to mine in data mining. but our focus will be mostly on supervised learning, unsupervised learning. Okay, and association learning, we will try to see an example. I will try to show you one practical example of how association mining works. I will try to show you the math behind it, because association is mostly these days has been replaced by some advanced algorithms. We don't use it that much right now, like in the custom setting we don't, but yes, the rules are definitely there: association rule minings and various other kinds of things. Basically, association rule learning is a type of unsupervised learning technique that basically checks for dependency of one data item on another data item, and it maps. Basically, it maps. It tries to find relationships. That is it. Don't need to worry much about that. It is basically, according to me, it's like part of unsupervised learning, you may say. But at times it can be a part of supervised learning. So it is like it's something between semi-supervised, like unsupervised and supervised learning, you may say. Okay. So next. Okay, now learning. Yeah, right. This is an example of how like association mining works. So it's basically the probability. Say someone who buys X also buys Y. So this is the conditional probability. You may have studied this in class your 12th or 11th in probability. That what is the probability of Y given X? Okay. So that is how we read this, that what is the probability of Y given X. And here is another example, that what is the probability that a person who bought chips also buys a beer. So the probability is 0.7, so the probability is very high. So that is what association shows us, basically. Okay, we try to associate things. It is basically just conditional probability. Okay. Okay, so this is an example of classification. Credit scoring. Here we are just trying to like classify points, data points which are on the low risk side, and classify points on the high risk side. Okay, based on some inputs such as from the incomes and savings. Okay, so that is a basic example of classification, where we just try to group items into certain groups, like yes or no, like group 1, group 2. There can be various kind of classification. Okay, where we basically try to group items. Okay, based on some labels given to us. Okay, classification applications, it can be like face recognition. Yeah, say there are 100 people with different face. So once they come, I detect their face and I tell, okay, this person is A, okay, this person is B. So that is a kind of classification. Character recognition, speech also. Yeah, say I have voice of some 1,000 people, and whenever they speak, I can tell, okay, this person is Madhav, okay, this person is Raju, and so on. Medical diagnosis is another example which can predict diseases. Okay, so this is an example of, say, training examples of a person. So we train our model using these faces, and then when these faces are shown to us, we just tell the names. Okay, this person, when the image is shown, I say this person is Harry. Okay, this person is shown, so this person is some XYZ or someone. Okay. Okay, so this is an example of regression. In regression, what we do is we just try to estimate some value. Okay. Say here is an example like price of a used car based on car attributes. Let's say your dependent variables X is say how many years the car is, how old the car is, what is the condition of that car, how many kilometers it ran, who is the owner, or no, not maybe the owner, how much was the price when it was bought, and so on. And depending on that, we give a price. Okay, after running it through our model, we decide, after we have learned the mappings, like how these things are changing, we just give out a price value. Okay. So in regression or any other like machine learning problem, what we are basically trying to do is learn the mappings. So say when we are trying to, I will discuss more about linear regression and things like that in detail later, but just to give you an intuition of what we are going to do, I just showed you this. Don't get afraid. Okay, regression applications. So there are various applications of regressions, a lot of application. Say you are trying to predict the price of a stock tomorrow or 1 month ahead. That is a problem of regression. Say you are trying to predict the weather or like temperature tomorrow. You are doing a regression, and so on. Okay, supervised learning uses prediction of future cases, knowledge extraction, and so on. Supervised learning is, as I told you, it is learning from already known outputs, and when the output is not there, it is unsupervised learning. Okay. Unsupervised learning, what normally happens, no output. As I told you, no output. Clustering is grouping similar instances. Like one of the most famously used algorithms for unsupervised learning is clustering. Clustering means grouping items. Okay, so we group them based on some common criteria, and we try to see what is the pattern. Reinforcement learning is basically learning from experiences. These are some examples like game playing, robots are usually trained using reinforcement learning. Various games are being played using reinforcement learning, and these are some examples where reinforcement learning is being used, where we try to learn on the go. We don't have any predefined like say data set for that. So what we do is we keep learning as we go. Okay, say one such example is one robot was made to play a game. I forgot the name, maybe it's Sudoku, and it kept learning after each move. It kept learning. It learns from the rewards or the punishments that it gets. Like the example I gave you, say you put your hand on fire and you get burned, so you got a punishment. You know that you don't do that again. Okay, but the next time when you go to say a lake and you put your hands inside that and you feel good, and you got that as a reward. And what you do is the next time you go to lake, you again put your hand in that and you feel better. Okay, so you have learned that. So you learn from the rewards or the punishments that you get. If you get a punishment, you know that we don't have to do this. If you don't get a punishment, you just keep doing that. You get rewards, you keep doing that. You know this is something that I have to do. Just like say people train their dogs. If they do a good job, they give him or her a treat. But if they do something wrong, they are scolded, so that they know that what they are doing is absolutely not right. Okay, so that is how reinforcement learning also works. Okay, so you can find some good data sets. We will be using one of them when in our practical sessions from ML repository, and there are also data sets here as well. So these are some of the websites that I have used for building this PPT. So this is basically a document from MIT. You can visit these sites for further reference. Okay, so these are some of the journals. These are some of the papers that I have read, which are really helpful. You can also give it a read if you want. Okay, so that's it for the introduction. So we will meet again on our next lecture, when we will try to see some practical implementations of these things. Okay, till then, bye bye, see you.